This is 2D flow with constriction. This is the ANSYS Fluent in which I have done the 2D flow with constriction. So this is the constriction, and this is the flow of air through the constriction, and this is the result of velocity contour. So one of my subscriber wanted me to perform the same analysis using non-Newtonian fluid. So let me just rename this one. This is a Newtonian fluid. So the experiment by default is a Newtonian fluid. Now let me just duplicate this one, and if you wanted to see the video of this part of 2D analysis with constriction, the link is in the description comment section. Please do check it out. So okay, now let me just rename this one non-Newtonian fluid. Okay, let me say clear generated data. Okay, so everything is same, geometry, meshing, all those is same. All we have to do is change our simulation physics setup from Newtonian fluid to non-Newtonian fluid. By default every simulation is Newtonian fluid if you don't set it up in non-Newtonian form. So okay, let me just save this project. Save project. Okay, now under model this is laminar, all those things same, but under material for air we are going to change viscosity from constant to non-Newtonian power law. By this we can change the fluid air with non-Newtonian fluid properties. So value 0.0102 and 0.46. okay, change, close. Now under cell zone condition, if you see flow domain, air, viscosity, non-Newtonian power law. Now the boundary condition is same as previous analysis. Okay, now let's come to method. Same, let's go to monitor, and I want to change the residual. I'm changing this to 10 to the power of -10 for better accuracy. So okay, now initialization, initialize. So as we can see, the hybrid initialization has been done. So now let's go to run calculation. So before I calculate, let me clarify one thing. It would be a lot better if you use a improved mesh. I have used a somewhat, let's say, a mesh good enough to produce a result, but I, for tutorial purpose, but I suggest use improve the mesh quality so that you can get better accurate results. So let me just now calculate. So now our solution has completed. So let me close the ANSYS Fluent. So now the result. So this is velocity contour with non-Newtonian fluid. As we can see, there is a high velocity at the center of constriction and nearly no velocity at the boundaries. Let's look at the streamline. Streamline. As you can see, the streamline. So if I just try to increase the streamline, you can see the flow pattern around the constriction. Let's compare it with the Newtonian fluid result. Edit. As you can see, the wave formation is there after the constriction in Newtonian fluid, whereas in non-Newtonian fluid there is no wave formation. Almost the flow is symmetric on the left to the right from the analysis. Let's look at the animation. Quick animation for streamline. Okay, let's reduce this to 20. So now this is Newtonian. Okay, play. You can see the wave formation. So let's close this one. We can also compare it to pressure. Let's see what's the pressure. There is a So this is the pressure distribution. Let's see what is the pressure distribution in non-Newtonian fluid. So that is the reference. Guys, thank you very much for watching the video.